All right, y'all. Welcome to 2.2b. Today we're going to take these factoring that we did in the previous lesson and we're going to use it to solve equations. So before we do that, let's review some of the factoring that we did last time with these three examples in this warm-up, A, B, and C. Give yourself a couple minutes, factor those. So if you're watching this video, hit pause, factor those, then we'll go over them. Are you ready? Did you pause? Ooh, hit pause if you didn't and work those problems. Okay, now let's take a look at A. We look for greatest common factor first. This does not have one. So then we look for how many terms it has, and there are two. When there are two terms, we look for either squares or cubes. These are both perfect squares. So we'll use, and they are subtracted. So we'll use the difference of squares form for factoring. Take the square root of 16x squared, that gives us 4x. Take the square root of 9y to the fourth, that gives us 3y squared. Now, this will factor into two parentheses, one with adding, one with subtracting. We put 4x at the beginning of each parentheses. We put that 3y squared at the end of each parentheses, and this problem is factored. Boom. Now, let's look at B. Again, we look for a greatest common factor first. It doesn't have one. We look at how many terms it has. There are two. So we look for squares or cubes. In this case, we have cubes. And remember, with cubes, we can factor the sum or the difference. That should be a third power. So we take the cube root of 27x to the third, or we say what to the third power will give us 27x to the third, and that's going to be 3x. Then we look at 8. 2 to the third power is what gives us 8. Okay? Now, if we remember that factoring formula, or we might give it to you when you need it. If you remember that factoring formula, if I can get the color I want here, it tells you that x cubed minus y cubed factors first parentheses x minus y, second parentheses x squared plus xy plus y squared. So we'll plug in what we need. Okay, so for the x in this formula, we're going to plug in the 3x from our problem. For the y in that formula, we're going to plug in the 2. Okay, so as we factor this, that first parentheses will have a minus. We'll have 3x minus 2 in that first parentheses. And then the second parentheses will have a plus sign and then another plus sign. That first term, we'll take the 3x and we'll square it. That second term, we'll take that 3x and multiply it by the 2. That last term, we'll take the 2 and we'll square it. All we did here was plug in to the factoring formula. Think of this factoring rule as the formula to plug in. Okay, so cleaning this up a little bit, or a lot, 3x minus 2 is good. Take the 3x and square the whole thing, so that's 9x squared. Multiply your terms in the middle, that's plus 6x. Then plus square the 2, and we get 4. This is completely factored. As long as you took out a greatest common factor in the beginning, and as long as that first parentheses is not another set of squares or cubes, this is completely factored. Okay? Now, let's look at C. Look for a greatest common factor. There's not one. Look at how many terms. There are 3 here. When there are 3 terms, we look for the magic numbers that have a product of the A times the C. So we need a product of negative 30. And they also need a sum of that middle term. So that's sum of 7. Okay, factors of 30, 1 times 30, 2 times 15, 3 times 10, 5 times 6. We need a negative 30, so we need a negative sign, but we need a positive 7, so we need that larger number to be positive and that smaller number to have the negative. So if we check out those pairs, negative 3 and positive 10 add up to be our positive 7. So we'll use those magic numbers and we will split this middle term into negative 3x plus 10x. Use the magic numbers we just found with the variable that was already on that middle term. So we'll still have a 6x squared. We'll still have a minus 5. Now there's 4 terms, so we group. Because we found a set of magic numbers, this is guaranteed to factor. So if we look at that first group, its greatest common will be 3x. Divide both terms by 3x. We get 2x minus 1. That 1 is important. It doesn't go all the way away. It divides out, meaning it equals 1. Bring down the sign in the middle. That's a plus. 10x minus 5 has a greatest common of 5. Divide both terms by 5. We get 2x minus 1. Now, this worked because our parentheses match. So one of our factors is 2x minus 1, and the other is 3x plus 5. And this is factored. So there's a little review of our factoring methods. Now we're going to take those factoring methods and we're going to solve by factoring. So to solve by factoring, make sure one side of the equation is equal to 0, meaning all of your terms are on one side. Factor the problem completely. Factor and factor again if needed. Set each factor equal to 0 and then solve each of those equations. Okay? So when we're solving these, if we look at example 1, sorry about that. If we look at example 1, go ahead and put an equals 0 on the end of these. Yeah, somebody forgot to put that in the document before it got uploaded here. So take a look at what we have. Always, always, always look for a greatest common factor first. This has a greatest common factor of 2. So we'll factor out a 2 first. I'm going to need to write small. Factor out a 2 first. We'll have 6x to the third minus 4x squared plus 3x minus 2. And that's still equal to 0. Now, on the inside, we need to group in greatest common. Don't forget that 2 is still a factor here on the outside. And this whole thing is still equal to 0. So that first group has a greatest common factor of 2x. When we factor that out, I meant 2x squared. And when we factor that out, we get a 3x minus 2. Then this second group, bring down the plus. 3x minus 2 doesn't look like it has a greatest common factor. So we use 1. We use 1. And then this stays 3x minus 2. And you're thinking, why did we need that 1? And here's why. One of these factors is 3x minus 2. The other factor is 2x squared plus 1. We need a term for this other factor. That's why we have to consider that 1 as its greatest common factor. And we have a 2 on the outside, and this whole thing is still set equal to 0. Now, step 3 says to set each factor equal to 0. Well, 2 is a factor, but if we set it equal to 0, there's nothing there to solve. So we don't worry about the constants. We don't worry about the constants. If there's not a variable, it won't cause a solution. So then we go to 3x minus 2, set it equal to 0, solve that equation. 3x would equal 2, x would equal 2 over 3. That is one of our solutions. X equals 2 over 3 is one of the solutions. Then the other factor, 2x squared plus 1, set it equal to 0. So 2x squared would equal negative 1. X squared would equal negative 1/2. So x would be the square root of negative 1/2, and that's a plus or minus. So this being a square root of a negative, this is not real. We're focusing just on the real solutions right now. So x equals 2 over 3 is our only real solution. X equals 2 over 3 is that only real solution. Now, look at example 2. X squared minus 16. Looks like a lot shorter problem. There's not a greatest common factor. There are two terms, so we look to see if they might be squares or cubes. These are squares, x squared minus 4 squared. So then this factors, one adding, one subtracting, x plus 4 times x minus 4. And put an equals 0 on this because we are going to solve it. Now, solving these, x plus 4 is equal to 0. So x will equal negative 4. And then solving the other one, x minus 4 equals 0. So x equals positive 4. And these are your two solutions. X equals positive 4 and x equals negative 4. Two solutions. Factor with difference of squares. Set each factor equal to 0. Solve those equations. Okay. On number 3, we're not actually going to solve this all the way out. We are going to factor only on this one. This is cubes, a sum of cubes. So we're adding those two cube terms together. 4x is what we raise to the third power to get 64, x to the third. Then 3 to the third will give us 27. So in our first parentheses, the sign is the same as the original problem, and it will be 4x plus the 3. In the second parentheses, the next sign is opposite. That last sign is always positive. We take the 4x and we square it for the first term. For the second term, we take the 4x times the 3. For that last term, we take the 3 and we square it. And then we need to clean this up. So 4x plus 3. Then 4x all squared is 16x squared minus 4x times 3 is 12x plus 3 squared is 9. And this is factored. We're not going to solve this one. The first parentheses will solve nicely. The second parentheses, we have to use some other methods on, and we'll talk about those in another lesson. Example 4, we have x squared plus 6x minus 6x plus 8. We have no greatest common factor. We look for how many terms. There are 3. So we need a product of 8. Remember, there's a 1 here in front of that x squared. Multiply that 1 and 8. And we need a sum of negative 6. So to multiply to 8, we need 1 times 8 or 2 times 4. To multiply to be a positive 8, the signs need to be both the same. But then to add to a negative 6, both signs need to be negative. So we have negative 2 and negative 4 that will multiply to be 8 and add up to be negative 6. Now, here's a shortcut. Because there was a 1 coefficient on this x squared term, these two magic numbers immediately make the factors. As in, one of the factors is x minus 2. The other factor is x minus 4. This only works when the x squared coefficient is a 1, like this one is here. So put an equals 0 on this problem, equals 0. Then set each factor equal to 0 to solve. X minus 2 equals 0, so x equals 2. X minus 4 equals 0, so x equals 4. And here are your two solutions. Now, let's look at example 5. There's a typo in this problem. My apologies. This 3 shouldn't be there. That 3 shouldn't be there. So we're just going to white it out. Now, there's four terms here, no greatest common factor, 4 terms, so we group. Group and greatest common. That first group has a greatest common factor of x squared. We factor that out. We get x minus 2. Bring down the plus sign. X minus 2 doesn't have a greatest common factor. So we use 1 because that really technically is its greatest common factor. Then x minus 2, we just divide all that by 1. So then this is all supposed to be equal to 0. Sorry, that got left off of these guys. Then x minus 2 is a factor, and x squared plus 1 is a factor. Those multiplied together equal 0. So then x minus 2 is equal to 0. So x equals 2. X squared plus 1, set it equal to 0. X squared equals negative 1. X will equal the square root of negative 1. That needs a plus or minus. And that's an I. That's an imaginary. That's plus or minus I. That is a non-real solution. That is a non-real solution. So x equals 2 is the only real solution to this equation. X equals 2 is the only real solution. That x equals plus minus I is non-real. All right, then let's look at, let's look at example 6. Let's look at example 6. First thing we always need to look for is the greatest common factor. And hey, this has one. This has a greatest common factor of 3. So factor out a 3. And we get 2x squared minus x minus 3. Then the inside of this has 3 terms. To factor 3 terms, we look for magic numbers. We would need a product of negative 6, and we would need a sum of negative 1. So to multiply to be a 6, we need a 1 of 6, 1 times 6, or 2 times 3. To multiply to be a negative 6, we need a negative sign. To add up to be a negative 1, that larger number needs the negative sign, so that smaller number will be positive. Then, if we take a look at this, we do have a set of magic numbers that works. 2 and negative 3 multiply and add to be what we need. So we will take those terms and we will split them, that middle term with it. So plus 2x minus 3x is what goes in the middle here. The 2x squared is still before it. The minus 3 is still after it. That greatest common factor of 3 is still out front. Now, on the inside, group and greatest common factor everything. Don't forget about the 3 that's on the outside. And we are setting each of these equal to 0. So in that first group, its greatest common factor is 2x. Factor that out. We get x plus 1. Bring down the sign in the middle. That's a minus. Then the greatest common factor of that second group is 3. divide by -3, and we do get positive x plus a 1. So those parentheses match, so it works. We got magic numbers. There were actual magic numbers here, so this should have factored, and it did. So one of our factors is x plus 1. One of our factors is 2x minus 3. And one of our factors is that constant 3. And this whole thing still equal to 0. Now we have 3 factors multiplied together to equal 0. Okay, 3 is a factor, but since it doesn't have a variable, it's not going to affect the solutions. So start with x plus 1, set it equal to 0. X equals -1 is a solution. Take 2x minus 3, set it equal to 0. So 2x equals 3, and x equals 3 over 2 is another solution. These are your two solutions. X equals -1 and x equals 3 over 2. And yes, just leave that as 3 over 2. Don't worry about making it a decimal, and please don't ever make that a mixed number. We don't need those. Okay, just leave that fraction 3 over 2. So, quick little recap. Whoops. To factor, to solve by factoring, make sure the problem is set equal to 0. Factor completely, factoring more than once if you need to. Then set each factor equal to 0 and solve each of those equations. You may get some non-real answers, and we'll work out how to deal with those in a future lesson. So that's it for 2.2b. Bye, y'all.